Welcome back. Today we are going to go ahead. We're going to take a look at this question. A lot of students have asked me this question, and basically it's just why are images reversed when in a mirror? Now, we can see down here, ambulance. This really does not say ensunambula, but it says ambulance, and it just says it backwards. Now, why do people do that? Why does the ambulance makers do that? So when you're driving along and you see it in your rearview mirror, you see it backwards. The images end up getting reversed in a mirror. Now, let's go ahead and let's explore how that actually works. Now, to do that, we need to know two things. First thing we need to know is what a normal line is. Now, this is a mirror that I just drew. Now, I'll put one down here, a normal line. A normal line is an imaginary little line perpendicular to a surface of reflection, and what it does, it helps you understand the incoming and the outgoing angles. If we have an angle of incident, we have an angle of reflection, and the angle of incident is always the same thing as the angle of reflection. Okay, now we're going to go ahead and we're going to draw you. It's actually easier if you have only one eyeball, so you're going to be a cyclops. You only have one eyeball right here. Okay, not sure why that happens. Here's an ear on this side. Here's an ear on this side. We're going to give you some bling bling in this ear right here, in your left ear. Okay? That's just going to help us to see the difference between your left ear and your right ear. Now, I'm just going to put a normal line right here, and let's see what happens. We got some bling bling. It's going to come. It's going to hit the surface of reflection. We have an angle here, maybe not a very good angle, but we have an angle there. And then we're going to have the same thing going out, the same angle coming out. Now, that ray of light completely did not hit your super cyclops eyeball, and so that's obviously not going to be the ray of light that you see. I'm going to take this normal line. I'm going to move it up. How about right about there? Try and get as perpendicular as I can. It's a little hard to draw on this computer. So you have an angle of incidence, an angle of reflection. That's pretty close right there. And so we're going to say this is the ray of light that actually comes from your ear, from the bling bling in your ear, into your eye. Now, what your eye's going to do, your brain's going to say, oh, well, it always goes in a straight line, and so it's going to project it back here, and it's going to say your ear with the bling bling is right about there. Now, same thing down here for this ear. I'm going to go off a point right about there. And we're going to say normal line. I'm going to put one right about here probably. We have an incoming angle, an outgoing angle. And your brain's going to project it. Oh, back here. Here's the other ear, filling in everything in between. Because there are light rays bouncing off everything in between. You have you. You have your reflection down here. Now, if you take a look, if this is, you're looking from above, if this is the guy's left ear, if you look at the reflection, the earring now looks like it's in the right ear. And so what we have going on here is we have a mirror image. And that's just a simple ray diagram just to explain why your image actually looks backwards in a mirror, why mirrors actually reflect, turn around, give you a mirror image of what's in them. Thank you. Hope this helps.